Okay, going to start the 12 o'clock Zoom meeting for Math 1111. And I hope you've gotten all the email messages that I've sent for instructions for the test tomorrow. Test to tomorrow. That's 2.1, 2, 3, 4, 6, 7, and 8. See your email for instructions. So we'll just work a few problems here. And I think we kind of went over and tried to explain everything on Monday's Monday's Zoom meeting. So it's off page 2.8, off page 262. And we'll start with, say, with number 8. Something like this. Is the function 1-to-1? Does it pass a horizontal line test? You can clearly see f of x here versus x. F of x is 1, 2, 1. Passes a horizontal line test. Oh, we have a participant. I can't see your name, but if you would like to ask some questions, let me very quickly turn a fan off so I can hear better. Okay, can you give me your name? Because with the camera on and everything, I don't have the screen on to see your name.
My name's Alex.
Okay. You have any questions today?
I was wondering if we could go over some in the practice test.
All right. Sure thing. Let me see if I can turn my volume up a little bit. Try to hear you just a little better. Yeah, I'm a little low. All right, let's see if I can find my copy of the practice test. I've got the blank copy and my key to it here. What would you like to see?
Hold on 1 second.
Okay.
Can we start with 2?
Sure. I'll go ahead and work it on the blank. Number 2. Number 2. Okay. You want to start at the beginning here?
Yes, please.
Okay. With the little circle, let me do one other thing and I'll be right back. Oh, actually, if you want to lay it off, I think
I was thinking, helping her out to explain what the educator was this. Right. She's good with it now. She's in. She was thinking she had to rush at the test.
okay.
And she know.
All right. I'm back with the Zoom. Okay, I'm back. So you want to start with part A, part B? From the beginning?
Yeah, we'll start from the beginning.
Okay. So the little circle means composition, means plug G into F. So this is read F in parentheses, then G of X. Okay. So then I put the g of x, formula for that there. I'm writing out all the steps. You may or may not need to do that. That would be f of x squared minus 4x. And then that's going to stick this formula in where the x is into f. So in effect, I've plugged g into f. And that's going to give me 1 over square root of x squared minus 4x. Questions about that?
No.
Okay. So then we asked for the domain. You want to see that?
Yes, please.
Okay. It's a square root. Ordinarily, I'm thinking greater than or equal to 0, but this one's tricky. It's on the denominator in the bottom. Takes away the or equal to. We mentioned that in chapter 1. Did we get that across? No.
Yes.
Or equal to, because it's on bottom. So I want to solve x squared minus 4x greater than 0. So this is why we did these kind of equations in chapter 1. Factor out the x, and you're left with x minus 4 greater than 0. The lead x would just be 0 itself. You remember, set each piece to 0. That's why you get an x equal 4 for the parentheses. 0 itself for the straight letter. So we are going to put on 0, put on 4, make them open circles. But you're going to have to test in between. So we go like -1. So I'm testing x equal -1. Then I'm getting -1 and then -1 minus 4. See, I'm using this line. Greater than 0, well, you're -1, and this is what, -5, although I don't have to work out -5. But sure enough, I get a +5 greater than 0. So yes, this is working. Are we going too fast?
No.
So somewhere in the middle here, I guess I'll go 1. Test x equal 1. That'll give me 1 times 1 minus 4 greater than 0. Well, my 1 is positive and 1 minus 4 is negative. Greater than 0, no. Because my positive times negative is negative, and that's not greater than 0. It's less than 0. So then I'm going to test x equal 5, I guess. And I will get 5 and 5 minus 4 greater than 0. Positive and positive greater than 0, yes. So again, there's a negative infinity on that end, infinity on this end. So my domain on the left end, negative infinity, comma 0, again with parentheses because it's an open circle. Pick up with 4 comma infinity with parentheses. Questions about that?
No, sir.
Okay, yes, that's what I got on my key. All right, you want to see the last 2 parts?
Yes.
Okay, I kind of scribbled this up, so to make it more readable, I did this. And that means I plug F into G. You want to shorten it up? Or do you want to see all the steps like up here?
We can do all the steps.
Okay, so that is G of F of X, which is G of 1 over square root of X, which is equal to 1 over square root of x. So I'm plugging 1 over root x in where the x is. And squared, subtract 4, 1 over root x. So this is acting like my x, and I'm square it and subtract 4 times it. And so I'm getting 1 over x, because the square root of x will just go, square root will go away. 4 over square root of x. Individually, you got kind of two pieces here. The x can't be 0. If you're looking at domain, I'll rewrite it 1 over x minus 1 over, or 4 over square root of x. This one says the x can't equal 0, so its graph, put an open circle at 0, shade either side. But then this piece, again, it's on bottom with the square root, so that takes away the or equal to. X has got to be greater than 0. So this piece would start with 0, put a closed circle. I'm sorry, it's still open, my fault. It's on bottom, it's still open. So that's open circle, but only to the right side. It can't be left of 0 with negatives. So when you put this together, you can't use this in this piece. It's going to go 0, open circle, shaded this way, 0 to infinity.
Gotcha.
Okay. So yeah, this is going to govern this. What else can we show you?
Let's see. Can we do 5?
5? Okay.
Well, good.
All right. Average rate of change.
Yes.
Okay. And you know you need y2 minus y1 over x2 minus x1. So you can call this your x2 and this your x1. Oh, it doesn't matter, you know, really doesn't matter. So on the bottom, you're going to get 4 plus h and then minus 4. So x2 here minus x1. That'll give h. All right. Do you see how to get y2 and y1? You've got to plug, since this is x2 and this is x1, you've got to plug that x into here, which makes 4 plus h squared minus 4 squared. Have we lost anyone?
No.
Okay. So then to finish, can you FOIL in your head or do you need to see all the steps? 4 plus h.
We can do all the steps.
Do all the steps. 4 plus h minus 16. Bottom is h. Okay. So you've got, I teach FOILing like rounds of distributive property. I've distributed 4 through both, write it down, then h through both. So 16 plus 4h. That's round 1. Then round 2 is h times 4, another 4h, and then h squared minus 16, all divided by h. I can squeeze this in. The 16s go away. You wind up with 8h, add h squared over h. Are we losing anybody?
No, sir.
Okay. So we factor out the h. 8 plus h divided by h. And the h's cancel, leaving the 8 plus h. That should be what I have on my key. Just double check. It is. Questions about that?
No.
Okay. Have another one?
Let's see. Can we do 7?
7. This is an exercise in plugging numbers into the formula. By the way, these are off the review sheet. Let's see. I guess I'll just go ahead and I just put the number down. I hope I punched it right, but I'll show you what we write down. I plug in with parentheses. 3, you got negative 2 cubed. Negative 2 squared. Add 5, you got negative 2 and minus 6. Everywhere there's an x, this is your x, you're sticking negative 2. The idea is, can you plug negative numbers into all these powers and keep your signs straight? So you're going to get a negative 8 times 3, negative 24. You're going to get a negative 16 here, because this is going to be a 4, but times negative 4 is negative 16. A negative 10 and a negative 6. Yes, there's my calculator. I hope this is what I punched in. I just wrote the number down. Negative 24 minus 16 minus 10 minus 6. Of course, I could punch it with the powers as well. I got negative 56. Please let that be what I got so I don't look like an idiot. It's a miracle. You want to see it punched with the powers on the calculator? I kind of did it half in my head, half on the calculator.
No, that was fine.
Okay. You want to see the other one?
No, I just wanted to make sure like that's what I was doing on that one.
Yep, that's what happens. Negative 56 when you plug in negative 2. What else?
Can we do a few from 10?
Okay. Oh yeah, I was trying to kind of collect all the cases of domains, kind of all at once, and see if you know what to do when formulas are put in fraction, don't have any problems, or they're put in fraction forms under square roots, square root with a fraction, pure square roots, square root on a fraction, and then something like this with no square root. So yeah, if you can keep all these different little formulas straight and what to do, then you know a lot of college algebra. So is there any particular part you want to see, or do you want to start from the beginning? And
You can pick some.
Okay, well, do you want to try to start easy, and then I work down to a little tougher here toward the bottom, last three.
Yeah, that'll be good.
So you want to just see the last three, or you want to see some of the easy ones too?
We'll see some easy ones.
Easy ones? All right, so you recognize this one has no problems? No square root or fraction? You don't really even have to draw a graph. It just, goes from minus infinity to infinity. So there's your domain. So then you stick it in a fraction. Again, you're setting this to 0. That means x equals 4, which means it's the number you can't use. So that busts up. Your first one is 4, open circle, but you don't have to test. So that goes negative infinity to 4 and 4 to infinity. So any questions about that?
So, because it's a fraction, it breaks it up
Breaks it up
at the 4.
at the 4. You understand why?
So if it was like any other number, like 8, then it would be negative infinity to 8.
Right. You would have busted it up at 8.
Okay.
If you want to,
Okay.
it
So-
really almost compares down to part G. This busted up into even more pieces. I didn't factor it for you, but that's 1 over like x minus 2 and x minus 3. So now you have 2 pieces on bottom. Up here you just have 1 with 1 number to bust it into. Down here you got x is 2 and x equals 3. You remember that?
Yes.
Okay. So again, there's no need to test anything. There's no inequality. So you just have a 2 with an open, a 3 with an open, and anything in between works. It's just 2 numbers to bust it up. So this one has negative infinity to 2, 2 to 3, 3 to infinity. That's a U, sorry. 3 to infinity. You only need to bust stuff up if you get an inequality, which occurs with square roots. So yeah, we will need to test. Actually, don't need to test this one. We'll need to test this. It's the quadratic inequality you got to test. Any questions about G? I'm trying to teach it as a simple extension of what you do in B. Does that make sense?
Yeah, no, I think I got it.
And so if I had, more factors, like we'd give you the fact, we wouldn't make you factor it if it had more factors. But if you just put more pieces on bottom, you just get more numbers that bust it up into, because there's more numbers where you'd be dividing by 0.
Yes.
Are you ready for the square root? All the others have got square root problems. Well, 2 of them also have square root 10 fraction problems. Are you ready for those?
Yes.
All right, now this one, see the square root's on top. So top, that means greater than or equal to 0. That means x is greater than or equal to 4. You can't stick in 3 or 2 or 1, any number less than 4. But you can't stick in 4. So that's going to put a closed circle at 4, shading right, making its domain with a bracket, 4 comma infinity. Questions about that?
No.
Okay. So then, see, I'm just trying to, instead of switching the numbers all around on you, although I did in part E a little bit, I'm just trying to put the same formula in different situations and see if you know.
Mhm.
what to do.
So
then
with C, it's a bracket because of the
equal to,
yeah, equal to. That's what I was trying to do.
you can include 4.
Gotcha.
If I did, I'd have a square root of 4 minus 4, which is a square root of 0. That's perfectly legal. But then when you take and put that square root on the bottom, that's what takes off the or equal. You can't use 4.
Okay.
You have 1 over the square root of 0. 1 over the square root of 4 minus 4 is 1 over the square root of 0, which is illegal. So all that does, it's going to be near identical to this. It's just going to change it to a parentheses. It's going to have x strictly greater than 4. Open circle at 4, shaded right. Infinities, if you want to see them. And then, so that changes it to a parentheses 4 comma infinity. So on top, it's a bracket. Bottom, parentheses.
Gotcha.
All right. Are we ready for the next one?
Yes.
Okay. Now this is back to being on top. So they're both greater than or equal to 0. So that's x greater than or equal to 4. 10 minus x greater than or equal to 0. So that's 10 greater than or equal to x. You can switch it around to x less than or equal to 10. So your x has got to be bigger than 4 for this, but it can't go, it can go up to 10, which works here. Go bigger than 10 and you got a problem here, like 11. 10 minus 11 is a negative. You got a problem. You got a 4, closed circle, 10, closed circle, in the middle. You're greater than 4, you're right of 4, but if you're less than 10, you're left of 10. So it's only numbers between 4 and 10 that'll work. That'll put you in brackets, 4 comma 10. Okay. Questions about that?
No. So, we switch it on the. I just want to make sure we switched it at with the 10 because
Honey.
of the negative.
No, actually I added the x over. It's when you have an inequality and you switch sides,
Mm-hmm.
inequality. If 10 is bigger than numbers, then those numbers have got to be less than 10, smaller than 10.
Okay.
So yeah, that's the other case. If you switch sides on an inequality, it switches the inequality.
Okay.
All right, so F is probably the toughest one. You ready for F?
Yes.
Okay. So you recognize the factoring here is x plus 2, x minus 2. You may have been a while since you've seen that pattern. Remember a difference of squares?
Mm-hmm.
And it's on bottom.
Mm-hmm.
So, okay. So it's on bottom. It takes away the or equal to. It's greater than 0. I got more room up here. So we're going to solve x plus 2, x minus 2 greater than 0. So your x is -2, your x here is 2. Let's open circles at them, -2 open, 2 open. But you get the difference between this and this. See, this is a straight equals. There's no need to test. You're only at 2 and 3, you can't use them because you're dividing by 0, and every other number works because there's no square root.
Mm-hmm.
But with the square root, you got to keep them positive. So some of these intervals may work negative. So we can try -3. I'd have -3 add 2, -3 minus 2. Greater than 0, can you see this works? Because you got a negative and a negative. Greater than 0, yes. See, the two negatives multiply to a positive.
Yeah.
Okay. Put 0 here, and you've got 0 add 2, 0 minus 2, greater than 0. Can you see that doesn't work? Because this is negative, but this is positive. So one negative is not greater than 0.
Mm-hmm.
And I think you'll see on the end here at 3, you'd have 3 plus 2, 3 minus 2, greater than 0. These are both positive, greater than 0, yes. So that's going to give you the two end intervals, -∞ to -2, combined with 2 to infinity. Yeah. So yeah, if you can run through all those combinations and understand correct domains on them, you know a lot of college algebra.
Okay.
What else can we show you?
Let's see. Mm, let's do 15.
Okay. All right. This is F divided by G. So that's going to take your F and divide it by the G. So it's pretty straightforward to write down. And then all we got to do is a domain, and it's the same exact idea. You ignore your top, and you want your, I think this is the second or third time we've done this on this page. You want that again strictly greater than 0 because it's on bottom. Means x strictly greater than 4. So open circle at 4. 4 comma infinity with parentheses. Is that too fast?
No.
Okay. What else can we show you?
So you just took it and put it in the form, and then with what you got with the bottom was your answer?
Well, I read this form. This says take the F and divide it by the G.
Mhm.
So that's what I did. I took the F formula divided by the G formula.
Mhm.
You just have to read what you get. And this is giving me a square root on the bottom. Square roots have to be generally greater than or equal to 0, but it's on bottom, which takes away the or equal to.
Mhm.
So if x minus 4 is strictly greater than 0, then I add the 4 over. X is strictly greater than 4. Can't use anything less than 4. Can't even use 4. That puts an open circle at 4, shaded to the right.
Okay.
What else can we show you?
Let's do. Oh, can we do 16? I'm a little confused on the inverse.
All right. So on 16, there were 3 steps. I'll go ahead and work your real. So I'll show you all 3 steps again. Step 1, you just sub in a y.
Mhm.
Is f of x, just to work with y. Seems to work a little better. So y is square root of 8 plus 5x. Step 2 is the key, switch x and y.
Mhm.
So where there's a y, put an x. Where there's an x, you stick a y. Then step 3 is you solve for y, and that's what'll undo everything. So you just have to read what you get and do the right things to solve for the y. With the square root, I want to square. So x squared equals 8 plus 5y. I'll take away the square root. Subtract 8. That'll equal 5y. Last move is to divide by 5. This is equal to my f inverse of x. I'll write it out for you. F inverse of x. Square the x, subtract 8, divide by 5. And you kind of see you have the inverse operations here. You got a square root, inverse is square. You're kind of adding 8 here, so you're subtracting 8. You're multiplying by 5 here, so you're dividing by 5. Questions about that?
I don't think so. Let me see. No, I think I'm good on that one.
Okay. What else can we show you?
Let's see.
Oh, that's fine. Sounds like you got some visitors.
Yes.
Okay. Yeah, I've had some visitors. I've had my house exterminated. Well, the pests in the house exterminated. So yeah, there's been some talking on my end too. Hope it wasn't too distracting. What else can we show you?
Can we do 18?
Okay. So 18, this is going to say multiply f and g. So that's going to take x squared minus 4x, f, and multiply by the g, 1 over x. Now you can leave it like this, that's fine. You can also kind of put them together, x squared minus 4x divided by x. And so if you look at this for domain, you've got a problem at x equals 0. Sure hope I listed that, number 18. Yeah, so your x can't equal 0. And so at 0, open circle. And again, 2 intervals, negative infinity to 0, 0 to infinity. Questions about that?
No.
All right, did you want to see 19? I have you plug G into F.
Yeah, that's fine.
All right. So that'll be F of my 1 over X. And that will mean 1 over X squared minus 4 times 1 over X. I'm putting 1 over X in for that X and for that. You can write that as 1 over X squared minus 4 over X. And I've got the same domain problem on both fractions. X cannot be 0. Squared doesn't matter. Still just a plain letter. So same idea, 0, open circle. Negative infinity to 0, 0 to infinity. Questions about that?
No.
Okay. Any others?
Can we do 20? And that'd be the last one.
Sure. All right, this is going to add the 2. So this is going to take F and add 2 over the square root of x plus 4. So this is kind of a combination problem. Got a straight fraction here and again a fraction with a square root. So the idea is, can you do them individually and put them together? All right, can you tell this can't be 0?
Yes.
Okay, so if you want to see, that's a 0 with an open circle, but you can go either side by itself. This is the 2 over x. All right, this is a fraction on bottom. It's got a square root. That takes off the or equal. So that is going to, in fact, I guess I should be doing the domain stand here. I guess I should have written this answer up here. 2 over x and add 2 over the square root of x plus 4. Okay, that's just the answer here. Then I just charged in the domains, maybe a little quick. So for 2 over x, x can't be 0. Rewrite it down here because it got a little compressed up there. 0, open circle, but either side, don't have to test. On a straight fraction, no square root, don't have to test. Just identify the number that gives you 0 on bottom and you can't use it. All right, so then when I have 2 over square root of x plus 4, that is strictly greater than 0. X strictly greater than 4. 4, open circle. Greater than would be this way. I'm sorry, -4. You let me get away with murder here. -4, because you'd be subtracting the 4 over. X plus 4 greater than 0 minus 4 minus 4. So that'd be x greater than -4. That's a -4 open circle, but shaded right. So you see how to put these together?
Yes.
-4 would be on this side. So together, start with -4, open circle, golly, what am I doing? Open circle, shaded this way. Now, I can't use anything this side of -4. All right, so then see -4 is over here. So I'm coming up, and now I can't use 0. So I'm going to have 0, open circle. And I've shaded this side. So I got to stay this side of -4. I could use 0 in this, but not in this one. So I got to block 0 out because I got them both together. Can you see how this goes? -4 to 0. That'll be this one. And then 0 to infinity. Questions about that?
Gotcha.
Okay. That's A and B. Did you want to see C or D?
Yes, please.
Okay. So basically, this is G of F of -2. I could do a general formula in X and then plug in the -2, but with the number, I just go ahead and plug it in. So can you see you're going to get first F of -2. That'll be 2 times -2 minus 3, putting -2 in for the X and F. -7. You got -4 minus 3 is -7. So that goes in here. So then finally, secondly, to get your answer, you need G of -7. Well, that'll be, 4 minus a -7 squared. You got to be really careful here. Plugging a negative into an even power gives you a positive 49, but that negative's still there. So I'm getting 4 minus 49, -45. Questions about that? Let's see, D and E.
Yes.
Plugging one into the other. Since I'm kind of short on room here, maybe you can just see it. I got to plug G into F. This is G into F. So that's going to put 2x plus 1 squared, add 2x plus 1. Don't really need a parentheses around that second 2x plus 1. This takes whatever, is inside here. F says square it and add it. So the G is this. I'm going to square it and then add it. You don't really have to do anything more with it.
Okay.
All right, this is F into F. You can wind your way through that. So this says whatever is in here, I square it and add it. So that means I'm going to take x squared add x squared add x squared add x. Is that too fast?
No.
And again, you don't have to really do anything with it. Didn't ask for the domains, but they're pretty simple domains if I ever did. Minus infinity to infinity on both. No fraction problems, no square root problems.
Okay.
Oh my goodness, time passes when you're having fun here. 50 minutes. What else can we do?
I think that was about it. I just wanted to run through real quick the practice tests and stuff. For the test, I know we have to do that browser thing, but is it like the same format as our quizzes, or is it more going to be along like kind of WebAssign where we are typing in the answer?
No, it'll be the same format as your quizzes and the first test.
Okay, cool.
I don't know if my instructions, if you happen to read them or anything, if it helps, I won't bore you to death with reading, but tomorrow morning, I'm going to give you a blank copy of the test that has the questions and a copy with those problems all worked out. Again, some correct, some incorrect.
Mm-hmm.
Okay, the actual test, when you get into D2L, will be numbered. The problems will be numbered 1 to 15. They'll all look the same. The problem is correct. It'll look like your Google form.
Mm-hmm.
That's where you're going to submit your true or false answers.
Okay.
Now, you may,
So basically, instead of a Google form, it's on D2L this time.
yes. This
Okay.
is the only time we're going to do this, again, just to keep the school happy.
Okay. Awesome. I just wanted to make sure.
Right. Now, one other thing, I cannot see your version of the Google, of the D2L form. It doesn't show it to me. So I don't know how you're going to enter your true or false answers. It probably isn't the same way as on the Google form. It may be as easy as just clicking a circle or a button on true or false. I hope it is. Can you hear me? I think my internet went shaky there.
Kind of. You're saying it could be just picking true or false?
That's what I'm saying. I'm really not sure, but it may be as easy as that. You may not have to type true or false like you do on the Google form.
Okay.
One other thing. I had one other thing. Oh yeah, the reason for mailing you out the form early is because once you enter D2L and enter that test form to enter your true or false answers, your computer is locked down.
Mm-hmm.
So you may or may not like that. My guess is you probably won't like it. So if you look at the test ahead of time, work out your true or false answers,
Mm-hmm.
then you can get into the D2L, enter the true or false answers pretty quick
Yeah.
without locking yourself down, you know, for hours. Just trying to give you a hint.
Yeah, I've had to use that program for other classes, so.
Okay.
All right, thank you so much.
Good thing. I appreciate you coming out today. Thank you very much.
No problem.
Appreciate it. If there's nothing else, I guess we'll go ahead and end.
That's it. Thank you.
Thank you.